Hi there, this video is sponsored by Shipin6, a like-minded crew of PLC software engineers who are bringing modern practices to automation. More on that later. God dag, guten tag, and good day. Today we're gonna have lots of fun because Arduino have released the new version of the Arduino PLC IDE, which has support for the Arduino OPTA. You remember the PLC that Arduino have released? So we're gonna play around with this guy, and we're not just gonna, but my ambition is that we're not just gonna run PLC code on it, but we're also gonna run traditional Arduino sketches, because that is what Arduino says is supported. You can apparently run sketches, so traditional Arduino sketches, written in C or C++, and PLC code at the same time. And that sounds very exciting, I think. So that's something I really want to try with this guy. So I'm not gonna keep talking, but let's just get started. I have already installed the IDE and the IDE tools because both of them have been updated. So both of these are already installed on my computer. And this is the new version. So let's create a fresh new project for the OPTA. Let's call it OPTA. And yeah, here we can see that Arduino have actually added the OPTA as a target. Because in my previous videos we were using the Portenta machine control, but now we're gonna play with this guy. Right. Everything looks as usual as in the previous videos, but we have the OPTA as a device now. So as you remember, with the Portenta machine control, we had to initialize the device with the PLC runtime by selecting the last port, so COM6 here, and do download. So I assume that this port, we can check the device manager. We have ports, so I'll just disconnect and connect this guy. So disconnected. I think port 6, yeah, there we go. And now I'll connect it again. So it's a little mix of Swedish and English here, but kommunikationsport means communication port. And yeah, we got this one when I connected it, so it should be this one. So let's just press download and see what happens. Okay. Cannot download sketch. Why is that? No upload port used. Maybe it's because I have the... I have a serial monitor for the OPTA running here. So that was a mistake by me. Because I actually installed... So again, you remember they actually released the OPTA before releasing the PLC development environment, which is a little weird, but anyway. But you could actually still use the OPTA by using traditional sketches, which I've been experimenting and playing around a little bit with. So that's what I've been doing. So I had this in the background. I will disconnect it or turn off the serial monitor, and let's try again. That seems to be working better. It's uploading to the internal flash. Okay. I don't know if it's ready. Let's try to connect to it, just like we did with the Portenta machine control. So for anyone that's never seen this before, please watch my previous videos where I do this, but with the Portenta machine control instead of the OPTA. I'm not gonna repeat all of that again. We'll connect to, okay, now we have another port here, so let's check the device manager, which makes sense, right? We should have two ports because it's a two-core PLC. Each and one of them has a serial port to communicate with. And in this case, I think it's the last one. At least that was the case with the Portenta machine control. So let's go there, connect. It works. And it actually detected all my interfaces. So I have the Wi-Fi version, you know, that has Ethernet, RS485, and Wi-Fi. And it doesn't have a license. With the Portenta machine control, I had to buy a license. I don't know whether... So what's gonna happen if I press this guy? Okay, license activated, so please restart. Like, restart how? Should I just plug it in and out, maybe? Let's try that. Cable, PLC, jump! And I'll try to connect again. Refresh. Oh! Worked, okay, beautiful. Beautiful. So you actually get a license pre-activated or pre-installed or whatever. You get a license with the PLC, so you don't need to buy an additional license like you had to do with the Prudenta machine control. That's really, really nice. Well done, Arduino. Okay, what are we gonna do now? I suggest let's try to just run a normal sketch on it, because I didn't do that in my last video. I only used the PLC part. So let's not do anything with the PLC right now, but rather let's go to the sketch here. So, okay, they added something here, libraries. Yeah, because I remember there was actually a restriction in the previous version where you couldn't add additional libraries. Now you can do it somehow. With the sketches, however, we should basically be able to do what I did here in the previous program. Let's try if it just works. So what I did here was that I simply, you can control this LEDs. There's a couple of LEDs on the PLC. So I was just turning them on and off, so blinking them. So let us just copy paste this code in here and see if it just works. I don't expect it to, but sometimes you get nice surprises, like Christmas. Well, actually not anymore. When I was a kid, it was fun. Now it's just boring, because the Santa Claus, Christmas man, Santa Claus, is it? No, it's Santa Claus in English, right? Christmas man doesn't make any sense. Anyway, let's try this. So let's just do a simple program. I mean, actually we already have a program. It's just incrementing a global counter, I think. Go to symbol. Yeah, that's a global variable. So there is a program running already. Yeah, so let's just see if this works. So a sketch and a PLC program at the same time, running what I presume is on 2 separate cores. Let's compile. Cold restart, sure. Okay, it compiled, so that's actually good. Okay, it's rebooting. Yeah, it has a very weird behavior. I think it works, but it's supposed to blink then a delay of 1 second and then stop blinking. But here, I don't know if you see it. Yeah, you see it. It gets this very short blink. Why is that? Let's just try to make this number 10 times. I mean, this is supposed to be in milliseconds, so it should be 1 second. But yeah, let's just see what happens if I do it this way. So I make it 10 times bigger. Because, I mean, if this works, it would be wonderful if I could run sketches simultaneously as I would run my PLC code. Because I imagine, for example, I used Arduinos for all kinds of stuff, but one of the things is, connecting them as an MQTT node. So if I could write an MQTT library, or even better, reuse one of the existing ones, run this part with MQTT, and then run my PLC code, just like dummy PLC code, and receiving and sending data through MQTT for the IoT stuff. That would be really beautiful. Now the problem is that it is working, but now it's just blinking this very short blink every 10 seconds instead of every second. Okay, I'm not gonna get too hooked up about this. Let's try to do something useful instead. So I know there is supposed to be a way to communicate between the PLC runtime and the normal sketch, and I discovered that there exist these shared variables, which I assume is for this particular purpose of exchanging data between the 2 different applications. So I thought, let's try doing that. I'm just gonna comment this. We don't need to be scared. And let's just create a shared variable. So how does this work? Is input to the PLC, or is input to the sketch? Let's just try something. And a number. Yeah, and a number, an integer. And how do I write to that? Do I just write a number? Or how does it work? Is this gonna compile? No, it doesn't. Okay, so after playing around a little bit, I discovered that you actually have to write PLC in dot. That's everything you need. Then it's gonna transfer it to this shared variable. And what's even better is that when you go to the PLC part, so to the project, it automatically shows up as an input here on the PLC side. So we can use this input here, just like a global variable or whatever in any program or function block or function or whatever. So this is really sweet. So let's just see if this actually works. So if I go online, I download. Okay, so that actually compiles. I think, you know, I'm just gonna make a counter here instead. Int counter, and let's do counter is. Oh, this is the problem doing PLC code and IT code at the same time. You know, the assignment operators are different. Counter +1, and we wanna assign it to counter, and we want to do a delay. So this delay, I'm suspecting there's something fishy about it, but there's something I don't understand here that is special compared to the sketches. But yeah, so what we're supposed to do is we're just incrementing a number, we put in that number to this shared variable, and we're waiting 1 second, and then we're repeating. So not rocket science. Okay, it compiled, it's working, so let's see. Okay, it's supposedly running now, so this guy should now have this value. The only question is, can I watch it? I probably can't. Wait, maybe I have to go online. I don't think I can watch it, so I probably need to copy it to a normal variable. So let's just do that. Let's do let's create another variable. Jacob, that's a, yeah, no fantasy, and it's gonna be an integer, and let's copy it over to Jacob. So Jacob is a number. So yeah, let's just see if this works. Download code, because Jacob I can do an online monitoring of, just like any other PLC variable. Okay, add to watch. Ah, it's working. Okay, amazing. Oh, that's okay, I didn't expect that to work, to be honest. I don't know, this is just my general assumption. I just always assume nothing is gonna work, ever, until I mess around with it forever and then it works. So this was quite smooth. So I'm actually having a note that Jacob is not incremented here. Jacob is incremented in the sketch. So I'm incrementing a number in the sketch, and then I'm transferring that to a shared variable that I'm using in my PLC code. That's quite neat. So which means that I expect if I would use this network adapter and everything in the sketch, you know, then I could do all of this nice IoT stuff that we're also used to doing when using an Arduino. I mean, that's what a lot of people are doing nowadays with Arduinos. And then, you know, transferring that information to the PLC code that could maybe turn on and off a relay, or, you know, talk Modbus to some other device, whatever. Endless possibilities. Before we continue, just a few words from today's sponsor.
Software engineering world and PLC world have been pretty separate in their histories. It's almost like separate evolutionary pathways. These pathways have a lot to learn from each other.
I think a software is kind of part of the soul of a machine. Software brings a machine to life.
To bring software engineering and PLCs together is something that we think is really important and revolutionary. Ship-in-6 is a part of Loop that almost nobody has heard of and knows that we do. And it's also the biggest and the fastest growing part of our company. We'd love to work with you on some sprints.
So what do we want to do now? Maybe we should try to actually do something useful. So I thought there's this example OPTA getting started. So this is what I used before the PLC IDE was actually available for the OPTA. But what they do here is that they have an example where they read one of the buttons. So you have some, you know, programmable buttons that you can use. A user button, quite neat, right? They have a button there that you can read, and in this example they basically just turn on different amount of lights, you know, LED lights. There's a couple of LED lights here, you know, depending on how many times you push on this button. So I thought we're almost going to do the same thing, but instead of turning on these lights, we'll transfer this information, you know, on the button, on how many buttons, how many times we press the button, to the PLC, and then the PLC can turn on the right amount of, so not turn on, but close the right amount of relays, right? Because the PLC has, it has 4 relays here at the bottom. So we can simply use that information instead to turn on the right amount of relays. So I probably need to hook this guy up to 24 volt, but other than that, I think this should be fairly straightforward. Let's start with writing the code. So let's do exactly this thing. We need to configure the button user input first. So let's not use these LEDs anymore. I hope there won't be any surprises. Counter here is going to be, n a number is going to be how many relays we want it to turn on. We need to read the button state. So let's just copy this guy. Probably that one as well. Let's remove all of that. Let's just clean up a little bit. Instead of change lights, we're gonna... Actually, I don't think we need that one. We just need the counter. That's all we need. We need to just send the counter. Let's transfer the counter to plcin.n. Maybe we should rename the variable. So, n number of relays. Yeah, it's not supposed to be pretty code here. This is just to check the concept. Is counter. So now we're simply checking. We're reading the button. If button state is low, which is it's pressed down, then increment the counter if it's less than 4. If it has reached 4, 0. Well, actually, we want this to be 5, right? Because we have 4 relays and we want to start with 0, 1, 2, 3, or 4 relays. Once it's 5, then we want it to go back to 0. So after the 4th, it will go back to 0. I'm just thinking here about triggering, whether this is going to cause any problems. I mean, let's see. Let's see what happens. We can always monitor this variable number of relays live. So we also have to change our program. We're not gonna write anything to any relay first. Let's just simply check that we get... I have to compile it probably. Let's just simply check that we get the right number. So Jacob is gonna be n number of relays. But first I have to compile it probably. Cannot compile sketch, why not? Because I'm calling change lights, which doesn't exist. So let's try again. Still not. Button state. Of course, this is the problem when you copy paste code. When you copy paste code and don't barely try to understand it, then you get punished. I'm fine with copying code. I do that all the time. I admit it. But I always try to understand it. Not just copy paste in blind, which I did now. I like this tiny exploration journeys on a boring afternoon. Okay, that seems to be working. Let's go online. Jacob is 0. I'm gonna press the button now. Yeah, it works. Oh, wait. It goes up to 5. So wait, maybe maybe I was a little too rushy. If count, yeah, of course it is supposed to be 4. Because if it's 3, it's gonna be 4. Oh, I'm so stupid. Yeah, okay. Okay, so I'll try again. I press the button. Now we imagine we have no relays. So again, I just want to remind everyone, I'm running a sketch here that's doing the logic. I mean, it's not hardcore logic, but you get the point. It's still running the sketch. And I have a PLC program that receives it and only increments and receives the number. And the watch window here is connected through Modbus to the PLC runtime, not the sketch. So this is the sweet stuff. Anyway, I'm gonna press the button now. Oh. Again, and now. Whoa! It works. This is great. So the next step is that we will have to connect this number that we received, that we have now safely stored in our PLC application, to turning on the right amount of relays. So let me just hook this guy up to 24 volt first. Okay, I got some beautiful, beautiful wiring done here. So it's probably good enough. Let's just continue doing the fun stuff, that is coding. Okay, so how do we control the relays? We have the hardware here, because we selected the OPTA, then Arduino of course knows how the hardware looks like. And we have the outputs here, so we can name this with a variable. That's how you work with the Arduino, with the development environment. So we can just call it, relay 1, relay 2, relay 3, relay 4, and then we can write to this from our PLC program. So let's do that. I'm not completely comfortable with this development environment yet. We're gonna do something very, very ugly here. We're simply gonna check. This isn't gonna be beautiful, but I just wanna verify that everything works. If counter, or let's do a case. Let's do an if. If counter is equal to 0, then all of the relays, not counter by the way, what I'm talking about. I want Jacob, or number of relays, yeah. If Jacob is equal to 0, then, well actually we can probably directly use number of relays. No, let's use Jacob. Or let's call it and number of actuated relays to make it even more confusing. If number of actuated relays is 0, then let's just directly write to these guys. Then relay 1 is false, because these are booleans, right? Yeah, they are. Good. Relay 2 is false. Relay 3 is false. And relay 4 is false. Else if this code gives my eyes cancer, but that's okay. Then only relay 1 is true. Then we're gonna do a couple of more else if. This is not how you're supposed to write structured text for everyone's information. Please watch the rest of my videos about modern software development practices to get an understanding of how your code should look like, especially my TwinCat 3 course, which is for free here on YouTube. It's not supposed to look like this, but you get the point. If it's 0, no relays. If it's 1, the first relay, etc, etc, etc. And I don't know whether I will actually hear them click or something, because I don't think even the LEDs are gonna be turned on, because there are LEDs here that indicate. So yeah, there are LEDs here to indicate which relay is on, but the thing is that we control these as well. So if we don't say that they should be on, then maybe they actually don't turn on. But we have LED outputs here as well, so we could actually control those as well. Yeah, why not? While we're having so much fun, then. Okay, that's weird. It doesn't allow me to rename it. That's fine. So it's the same concept here. So let's go. Yeah, I mean, if these work, then the relays are probably going to work as well. So the only thing we want to test here is that the data is transferred, and we can use this data to do some logic in the PLC. And then project. And let's do the same thing here. So LED 1. All of the LEDs should be off. And in this case, the first LED should be on. This case, the first 2 should be on. And in this case, the first 3 should be on. And in the last case, where number is 4, then all of the guys should be on. Okay, let's compile and see. get an error. Why did I miss something? Yeah, it's something weird here with the Arduino compiler that you need to finish and if with a semicolon. I think. Yeah, no errors. So in Twinket you don't need to do that. Yeah, but it's running now. So let's put a watch on this variable. Number of actuated relays at the watch. It's 0. I will press it now. It's the button here. Okay, I'll press it. Oh yeah, you can actually hear the relays. So I'm gonna put this guy really close to the microphone. And yeah, here I will press the button now. Here. Ah, that's really cool. And the let's see if we get you see the LEDs, so I'll press. See? And we can just hold the button. Like a train. It's working! It's fun. I love playing with new toys and new stuff. But again, I mean, I think you understand this example, right? We don't do anything, you know, we're not doing any increments or anything of the number of relays here or anything with the buttons. We're doing that in the sketch. And then we transfer that information to the PLC code. And we can actually do the other way around. So we have inputs for the PLC code and outputs. So we can do stuff in the PLC and send that to the sketch, you know. So again, just example, if the sketch did something with the web, you know, something with IoT, then, you know, the PLC could do some logic, measure something, measure some temperature, send it to the sketch and then out on the cloud. So endless possibilities. Well, that's it for this video. I hope you enjoyed it. If you want me to continue making videos like this, then please hit that like button, subscribe if you haven't subscribed already, and see you in the next video, and happy coding!